Hello, welcome to another round of CMI Lab sessions with me, Senior Solutions Architect Lance Hawks. Today we're going to talk a little bit about the IBM Power8 processor. It was recently announced last August at the Hot Chips conference, and a lot of good things were said about this. Some really interesting differences between this and IBM's latest processor, the Power7 processor. Let's talk a little bit about some of those differences. The Power8 processor is 22 nanometers, silicon on insulator processor. Really means nothing other than it's really small. It's going to have 12 cores, and another huge improvement is SMT8. I don't know, Power7 was SMT4 or simultaneous multi-threading 4. What does all this mean? So SMT8 means that for every tick of a processor clock, the processor can handle 8 instruction sets, 8 threads of instructions. So if you have an application that's highly threaded or able to feed the processor a lot of information, it's highly efficient at that. Compare that with Power7, it was simultaneous multi-threading 4, and with other Intel x86 processors out there, those can only handle 2 threads per instruction cycle. So you can see that's a huge improvement. But what that also means is that the processor really needs to be fed. It's really, really hungry. So to allow for that processor to be fed, IBM made some drastic improvements on bandwidth, on memory, and on cache throughput. You can see here, and I've just highlighted some of or noted some of them, and we're not going to spend a whole lot of time talking about these things. This one is of note though. It's up to 230 gigabytes per second of sustained bandwidth. So this processor is ready for those applications that can really, really feed it. What you're really going to see is about 1.6 times the thread performance, or 2 times the SMT performance over previous processors, the Power7 processors. For your applications, that means that that's 2 to 3 times the improvements in performance, especially for those transactions that are, or for those applications that are highly transactional. Small payload applications like TIBCO or the Lawson Financials. It's no slouch with single-threaded applications either, though. It's really going to excel at applications, you know, those applications that are often spoken about today, like big data or data analytics or cognitive computing. You know, all of those applications have a tremendous amount of data that needs to be crunched. This is the processor that you're going to want to do that crunching. You know, in the past, recently, there have been a lot of improvements in data center performance overall, especially with the advent of flash and solid-state disks, and the improvement to from 1 gig Ethernet to 10 gig Ethernet, and now you've got 40 gig Ethernet in some of the data centers. So what that essentially does is it moves the bottleneck around the data center. Well, IBM is prepared to make sure that that bottleneck doesn't stop with their processors. So this, the Power8 processor is able to improve the overall performance improvement, or the overall performance footprint of your data center. And you're going to be able to consolidate tremendous amounts of workload on one of these boxes with the Power8 cores. We don't really know, IBM hasn't announced exactly how they're going to package these processors, but for example, if you think about a 4-socket system, which is typical, you're looking at 48 cores. In the past, IBM's done that in a 4U size, so 48 cores in 4U, and with SMT8, that's 384 cores. So you can be well assured that your applications are going to be very satisfied at pushing data into these cores. The UK Register, in fact, at the Hot Chips conference shortly thereafter, they wrote that the Power8 is by far one of the most elegant chips that Big Blue has ever created. Also, the Linley Group also reported that the Power8 specs are mind-boggling. IBM's newest server processor will smash existing performance records, particularly for memory-intensive applications. IBM's ready. Let's bring your applications and let's get this ball rolling. Look forward to doing more of these Geek Speaks with you in the future. Thanks.